Welcome back to the What Is channel, the only place on the internet where we tackle the big questions while you're probably sitting in your pajamas eating cereal. Today, we're looking at something so obvious you've probably never actually thought about it. We're asking, what is light? Now, before you say, I know what light is, it's the thing I turn on when I'm scared of the basement, let me stop you right there. Light is actually one of the weirdest, most rule-breaking, logic-defying things in the known universe. So, what is it? Is it a wave? Is it a particle? Is it traveling so fast that it's technically a time traveler? Let's flip the switch and find out. First, let's talk about speed. Light is the undisputed heavyweight champion of the universe when it comes to going fast. It travels at roughly 300,000 kilometers per second. To put that in perspective, light can circle the entire Earth 7.5 times in a single second. If you could travel at the speed of light, you could go to the moon and back during a particularly long yawn. Because light is so fast, everything you see is technically in the past. When you look at the moon, you're seeing it as it was 1.3 seconds ago. When you look at the sun, you're seeing it as it was 8 minutes ago. If the sun suddenly disappeared right now, poof, gone, cosmic magic trick, we wouldn't even know for 8 minutes. We'd just be standing here, enjoying the warmth, totally oblivious to the impending frozen darkness. It's the ultimate. This could have been an email delay from the universe. But what actually is light? For centuries, scientists fought over this, like people arguing in a YouTube comment section. On one side, you had Isaac Newton. He thought light was made of tiny little balls called corpuscles, which is a word that sounds much grosser than it actually is. He figured since light travels in straight lines and bounces off mirrors like pool balls, it had to be a particle. On the other side, you had guys like Christian Huygens, who argued that light was a wave, like sound or ripples in a pond. They pointed out that light can bend around corners and overlap with itself. The crazy part? They were both right. And they were both wrong. Welcome to the headache that is wave-particle duality. Light behaves like a wave when it's traveling through space, but it behaves like a particle called a photon when it interacts with matter. It's the ultimate identity crisis. It's like being a liquid while you're walking to work, but turning into a solid the second you sit in your chair. It's weird. It defies common sense, and it makes physics students cry during midterms. Now, let's talk about the visible spectrum. This is the tiny, tiny sliver of light that our puny human eyes can actually see. You know it as the rainbow: red, orange, yellow, green, blue, indigo, and violet. But here's the kicker. The light we see is just a fraction of what's actually out there. Light is officially categorized as electromagnetic radiation, and that family is huge. On one end, you have radio waves. Yes, the music coming out of your car is being carried by light that is so low energy, your eyes just ignore it. Then you've got microwaves, which are basically light waves vibrating the water molecules in your leftover pizza until they get hot. On the other end, you have the spicy stuff. Ultraviolet light, which gives you a sunburn. X-rays, which look through your skin to see if you actually broke your toe, or if you're just being a baby about it. And finally, gamma rays, the highest energy light in the universe. If you see those, you're either about to become the Hulk, or, more realistically, you're having a very bad day at a nuclear level. So, why do things have color? Why is a banana yellow? When white light, which is actually a mosh pit of all colors mixed together, hits an object, that object absorbs some colors and bounces others back. A banana absorbs every color in the rainbow except yellow. It rejects yellow. It says, "Get out of here. Yellow, I don't want you." That rejected light is what hits your eyes. So, technically, a banana is every color except yellow. But we see it as yellow because that's the part it didn't want. Perspective is everything, isn't it? And here is where it gets truly mind-bending. Light is the universal speed limit. According to Einstein, the guy with the hair, nothing with mass can ever go as fast as light. As you get closer to the speed of light, time actually starts to slow down. If you hopped on a spaceship and traveled at 99% the speed of light for a few years and then came back to Earth, you'd find that decades, or even centuries, had passed. You'd be young, and everyone you knew would be voo. Let's just say they wouldn't be inviting you to brunch. To a photon, time doesn't exist at all. From the perspective of a particle of light, the moment it is created in a star, millions of light years away, and the moment it hits your eye happen at exactly the same time. It experiences the entire history of the universe in 0 seconds. It's the ultimate shortcut. Light is also how we know what the universe is made of. By looking at the light from distant stars, we can see spectral lines, basically a chemical barcode. We can tell what a star is made of without ever going there. We know there's helium on the sun because we saw it in the light before we ever found it on Earth. Light is the universe's way of sharing its secrets, provided we're smart enough to read the code. Without light, there is no sight, obviously, but without light, there is also no life. Photosynthesis is the process of plants literally eating light to create energy. You are essentially eating repackaged sunlight every time you have a salad. Or a burger, since the cow ate the grass that ate the light. You are a light-powered organism living on a rock that is orbiting a giant light bulb in the middle of a dark, cold vacuum. Everything we understand about the cosmos, from the Big Bang to the edge of black holes, comes down to us catching these tiny, vibrating packets of energy. Light is a messenger. It's a constant, it's a rule maker and a rule breaker. It's the reason you can see this video, and it's the reason we can see the beginning of time itself. So, the next time you flip a switch and the room brightens up, take a second to appreciate the 300,000 kilometers of chaos that just happened so you didn't stub your toe on the way to the kitchen. If you enjoyed this deep dive into the bright side of physics, make sure to hit that like button. It helps the YouTube algorithm find us. And the algorithm is basically just a very complicated series of light pulses anyway. Don't forget to subscribe to What Is for more answers to the questions you didn't know you had. Drop a comment below and let us know. If you could travel at the speed of light, where's the first place you'd go? Personally, I'd go to the edge of the universe. Or maybe just to the front of the line at the DMV. Thanks for watching, and keep looking for the light.